Good morning, students. Today we shall start the new lesson integrals. It's a part of calculus. We already know about calculus. Differential calculus we already studied. We finding the derivative of the functions and application of derivatives in many fields. We already solved many problems on differential calculus. Today, we shall study about integral calculus. In calculus, two types, differential calculus and integral calculus. In integral calculus, in this differential calculus, we have to find the derivative of the functions. Derivative of a function. In integral calculus, if derivative of the function is known, if derivative of the function is known, then we have to find the function. We have to find the function. If a function is derived in an interval, then we know f dash x, derivative of the function. We have to find f of x of this derivative. This process is known as we have to find this process is known as integration. Is known as integration. We have to find the function to the derivative of the function is known as integration. In integration, we have to find one is finding the function to the derivative, and another is we have to find area, find the area of a curve, bounded area of a curve, bounded area. Here, this area we have to find by using integration of a calculus. Integration is the inverse process. It's the reverse process. Process of differentiation. Integration is the reverse process of integration, differentiation. What is the reverse process? You remember 2 square is 4. Then square root of 4 is equal to 4. Here we have to find the square of the integer 2. It's equal to 4. Then we find the square root. It's 2. In the same way, d by dx of x square, which is equal to 2x. We find the reverse process. It's the integration. It's the 2x is the derivative of the function. If we find the integration of 2x is equal to x, integration of 2x is equal to x square. The same way, we have to find derivative. We know the derivative of the function is derivative of the function x square is 2x. Then integration of 2x is x square. Yeah, we have to find x square. Differentiation is 2x. Then integration is integration of 2x is x square. First we find the integration of a function derivative which we know about, which is the derivative and which is the function. Then we solve many other problems. Integration, integrals in two types. There are two types. One is indefinite integrals. Another is definite integrals. First, we know about the indefinite integrals. Indefinite integrals will find the area of the bounded curves. Here, indefinite integrals we find the function with of the given derivative. We use the integration in finding the derivative of the function to the derivative and solving the problems on engineering field and economic field, finance field also. We solve many problems on by using integration. Today we shall study about definite integrals. First, we solve some problems like which we know about the definite integrals. D by dx of sin x, which is equal to cos x. Second one, d by dx of x cube, which is equal to 3x square. Third one, d by dx of e to the power x, which is equal to e to the power x. Since antiderivative of cos x is sin x. Then antiderivative of 3x square is x cube and antiderivative of e to the power x is e to the power x. The same thing. But sometimes constant is there. Like d by dx of x square plus 5. Derivative of this one is 2x. Derivative of constant is 0. Here d by dx of x square also is equal to 2x. X square also equal to 2x. X square plus 5 also is equal to 2x. If we write the antiderivative of 2x, here is x square plus 5. We write it as x square only. Here it is x square. Here it is x square plus 5. But antiderivative of 2x is x square. The constant is not there. Therefore, we have to write this constant, arbitrary constant. We should write the arbitrary constant x square plus c. Antiderivative of 2x is x square plus c. C may be, here is 5, here is 0. Therefore, in indefinite integrals, we have to write constant c. Constant c. Therefore, integration of or antiderivative of sin x, antiderivative of cos x is sin x plus c. If constant is there or not there, we should write antiderivative of any function of e to the power x is e to the power x plus c. We should write c always in writing the differential integration of the indefinite functions. Therefore, we solve some generally d by dx of generally, if there is a function c, f, generally we can write if f is a function such that d by dx of f of x is equal to small f of x for all x belongs to I interval. D by dx of f of x, capital F of x is equal to f of x is the derivative of this function. For all x belongs to I, it's an interval. Then for any c, then c be any arbitrary constant. Then d by dx of f of x plus c, which is equal to f of x where x belongs to I. Here d by dx of f of x is equal to f of x. Then d by dx of f of x plus c also is equal to f of x. Here c is a constant, its derivative is 0. But antiderivative, we should write c. Here also we should write c, but c is equal to 0. Thus, f plus c is belongs to R, there's family of antiderivatives of f. Antiderivatives of, yeah, here we know that d by dx of x square is equal to 2x and d by dx of x square plus 1 is equal to 2x. d by dx of x square plus 3 is also equal to 2x. Here 1, 3 are the arbitrary constant, but we should write always 2x is the constant. Therefore, we always write integration of antiderivative of 2x is equal to x square plus c, because these are denotes the family of antiderivatives. Family of antiderivatives. Always you should remember to write plus c in solving the problems of indefinite integrals. Finding the indefinite integrals, we should write plus c. Here we write the antiderivative of the function, but the process is different function to function. The indefinite integral of f of x with respect to x is written as integration of f of x dx. It's the integration of f of x. It's the antiderivative of f of x. Then it is equal to written as integration of f of x dx is equal to f of x plus c. F of x is the derivative of the function. Then f of x is the function. It is the derivative. It is the function. Here, it's the symbol of integration. This is the symbol of integration. It's integral. We have to write f of x is called integral. And dx signifies the variable of integration. Then c is constant of integration. Here, integration of f of x dx is the f of x plus c. Here, f of x is called integral. And dx signifies the variable of integration. Variable is with respect to x. Here variable is integration of x square dx. We have to write x square. We find the integration with respect to x. If we t square, integration is t square, we should write dt. If it is sin square theta, we should write d theta. It's the constant of integration is c. It's the c. In indefinite integrals, we should write c. Is the constant. Yeah. dx is signifies the variable of integration. Here dt. T is the variable. Here theta is the variable. You should not write x square with dt. You should convert x square in terms of t. Here also, we should write theta and d theta. If we write x, here also x. I think you know about the symbol of integration and variable and constant. Should write constant also. Then we recall the derivative of the function and their integration, antiderivatives. First one, I will write the derivatives here. I write the integration this side. First, d by dx of x to the power n plus 1 n plus 1 d by dx of x to the power n plus 1 divided by n plus 1, which is equal to, don't write it, x to the power n is equal to x to the n into x to the power n minus 1. But here we have to write n into x to the power n minus 1 is equal to dx is equal to x to the power n. I will write about x to the power n dx. X to the power n dx. Therefore, I write here x to the power n plus 1 divided by n plus 1. Here, derivative of the function is x 1 by n plus 1 is constant. 1 by n plus 1 is constant. Then n plus 1 into x to the power n plus 1 minus 1, which is equal to n plus 1 gets cancelled. Therefore, x to the power n is the derivative of the function. Derivative of x to the power n plus 1 divided by n plus 1 is equal to 1 by n plus 1 is constant. I think you remember all the derivatives of the function. X to the power n d by dx of x to the power n is equal to n into x to the power n minus 1. Here, I write 1 by n plus 1 is constant. Then n plus 1 into x to the power n plus 1 minus 1 plus 1 minus 1 gets cancelled. We write x to the power n. Therefore, x to the power integration of x to the power n dx is equal to x to the power n plus 1 divided by n plus 1 plus c. Second one, integration of x to the power 1 dx. 1 dx. Here, we should write here x to the power 5 minus. Then x to the power 5 plus 1 divided by 5 plus 1 plus c, which is equal to x to the power 6 by 6. In the same way, we can write x to the power 10 dx. We can write x to the power 10 plus 1 is 11 divided by 11 plus c. Yeah, we can write the integration by using this formula x to the power n is equal to x to the power n plus 1 divided by n plus 1. How can we get this? Is we know about the derivative of the function. It's the antiderivative of the function is x to the power n. In the same way, we can solve all these type of problems. Next, we shall go to the derivative of 1. Derivative of 1 dx. It is equal to x plus c. Because derivative of x is 1. Derivative of x is 1. Therefore, 1 integration of 1 dx is equal to x plus c. In the same way, x to the power minus 5 dx, which is equal to x to the power minus 5 plus 1 divided by minus 5 plus 1 plus c, which is equal to x to the power minus 4 divided by minus 4 plus c, which is equal to minus x to the power 4 plus c. The same, or we can write it minus 1 by 4 x to the power 4 plus c also. It's the integration of the type of x to the power n dx. X to the power n dx. I think you can understand to solve this type of function x to the power 15 integration of x to the power 15 dx is equal to, write your answer, x to the power 15 plus 1 is equal to 16 divided by 16 plus c is the integration of x to the power 15. Next, we shall go to the derivative integration of cos x dx. First, we know about the derivative of dy dx of sin x, which is equal to cos x. You know, dy dx of sin x is cos x. Therefore, cos x is sin x plus c. Next, dy dx of cos x is equal to minus sin x is equal to minus sin x. Therefore, integration of minus sin x dx, which is equal to cos x plus c, or integration of differentiation of minus cos x is plus sin x. Therefore, integration of sin x, or I write it plus sin x, is minus cos x plus c. First, you remember here, derivative of sin x is cos x. Derivative of sin x is cos x. But integration of sin x is minus cos x. Integration of sin x is minus cos x. Cos x is minus sin x. Cos x is plus sin x. In the derivative of cos x is minus sin x, but in integration of cos x is sin x and sin x is minus cos x. Fourth one, integration of next d by dx of tan x, which is equal to secant square x. Therefore, integration of secant square x dx is equal to tan x plus c. Tan x plus c. In the same way, d by dx of cot x is equal to minus cos x square x. Here, we know that minus cot x is plus cos x square x. Therefore, fifth one, integration of cos x square x dx is equal to minus cot x plus c. Cos x square x is tan x and cos x square x is minus cot x. You perfect about the derivatives of the function, you can easily find the integration of the derivatives of the function. Then sixth one, d by dx of sec x, which is equal to sec x for sec x tan x and d by dx of cosec x cot x is equal to minus cosec x cot x is equal to cosec x equal to cosec x cot x. There is a minus. You can write d by dx of minus cosec x is equal to plus cosec x of cot x. Therefore, we can write sec x tan x dx because it's the variable here is x. Therefore, we should write dx. Therefore, find the integration of sec x tan x is sec x plus c. Then seventh one, integration of minus cosec x cot x is equal to minus cosec x plus. Then you understand about the integration of e to the power x dx is equal to e to the power x because d by dx of e to the power x is equal to e to the power x. So e to the power x plus c. Then you should write the inverse functions, derivative of inverse functions. You should know the derivative of the inverse function, then we find the integration. d by dx of Take 1 d by dx of sin inverse x is equal to 1 by square root of 1 minus x square. Then 1 d by dx of cos inverse x is equal to minus 1 by square root of 1 minus x square. Then 1 d by dx of tan x, tan inverse x is equal to 1 by 1 plus x square is the integration of the derivative of the function. Then we find the integration of 1 by square root of 1 minus x square dx, which is equal to sin inverse x, or which is equal to minus sin inverse cos inverse x also. You can write minus cos inverse x also. Because sin inverse x derivative is 1 by 1 minus x square root of 1 minus x square. Derivative of cos inverse x is minus of 1 by square root of 1 minus x square. Therefore, you can write, change the sign here, it's a plus. Therefore, 1 by square root of 1 minus x square integration is sin inverse x or minus cos inverse x. Nine one x. Then 91 d by dx of tan inverse x integration of 1 by square root of 1 plus x square dx is equal to tan inverse x. Then 1 is d by dx of cosec inverse x, sec inverse x, and cot inverse x. Here, cosec inverse x is 1 by x into square root of x square minus 1. Here it is minus. Then x square x is equal to 1 by x into square root of x square minus 1. Cot inverse x is minus of x square 1 plus x square. Therefore, we can write integration of 1 by 1 plus x square dx is equal to minus cot inverse x. Here, square root of 1, integration of 1 by square root of 1 minus x square dx is equal to sin inverse x, or is equal to minus sin inverse x. In the same way, integration of 1 by 1 plus x square dx is equal to tan inverse x, or in fact, integration of 1 by 1 plus x square dx is equal to minus cot inverse x. Then cosec inverse x and sec inverse x. Integration of 1 by x into square root of x square minus 1. That's plus c plus c and plus c and plus c. Should write always plus c in independent integrals. X by square root of x square minus 1 is cosec inverse x, here it is minus or equal to sec inverse x. Yeah, you can write two variables of integrals, two functions. derivative of minus cosec inverse x is equal to 1 by x square root of x square minus 1, and derivative of sec inverse x also 1 by x into square root of x square minus 1. Next, into this power I already did the integration of, yeah, 11 divided by dx of 1 by log x. So, log x is equal to 1 by x. Integration of log x is equal to 1 by x. Therefore, 1 by x dx, which is equal to log x plus c. Here, x to the power n integration dx is equal to x to the power n plus 1 divided by n plus 1 plus c. But here is x to the power minus 1. Here should not x is not equal to minus 1. In this formula, we should always write n is not equal to minus 1. If it is minus 1, x to the power minus 1 plus 1, this is equal to x to the power 0 is equal to 1. It's not true. Because here d by dx of log x is equal to 1 by x. Therefore, integration of 1 by x dx is equal to log x plus c. Then here always x is modulus. Next one, a to the power x d by dx of a to the power x. A to the power x is equal to a to the power x into log of is the answer. Then here integration of a to the power x log a. Okay, right. A to the power x divided by log a is the answer. Therefore, d by dx of a to the power x is equal to a to the power x log a d by dx of a to the power x log of a, which is equal to a to the power x. Therefore, integration of it is to take the log in this side, then write a by x or multiply a by x. You can write this one because here d by dx of a to the power x is equal to a to the log of a is constant. Log of a is constant. 1 by log of a is constant into a to the power x into log a. It's just cancel. It's equal to a to the power x. Therefore, d by dx of a to the power x log of a, which is equal to a to the power x. Therefore, integration of a to the power x dx is equal to a to the power x divided by log of a plus c is the integration of the function a to the power x dx. In this way, we solve the other problems by using this, formula. We find the antiderivative of the function which we know the or the derivative of the function. But sometimes we don't know about the derivative of the function, then we find the integration of the derivative and find the some properties of indefinite integrals. The process of differentiation and integration are inverses inverses of each other. You already know the process of differentiation and integration are inverse of each other. Therefore, d by dx of integration of f of x dx is equal to f of x then integrate or f dash x dx is equal to f of x plus c. Where c is an arbitrary constant. So let f be any antiderivative of f, then d by dx of f of x, which is equal to f of x, d by dx of f of x is equal to f of x, which leads to integration of f of x dx is equal to f of x plus c. F of x plus c and d by dx of integration of f of x dx is equal to d by dx of f of x plus is equal to d by dx of f of x, which is equal to f of x, which will type then f of x. Then only we can d by dx of f of x, integration of f of x is equal to small f of x. Integration of f dash x dx is equal to f of x plus c, where c is an arbitrary constant. Let f be an arbitrary and any antiderivative of f. F is an antiderivative of f. D by dx of derivative of f of x is equal to f of x, small f of x. Then f of x, integration of f of x dx is equal to f of x plus. It's the antiderivative. Or integration d by dx of f of x. Similarly, we know that f dash x is is equal to d by dx of f of x. Hence, integration of f dash x dx is equal to f of x plus c. It's the reverse process. Integration is the reverse process, and differentiation also reverse process of integration. In the same way, we can write the process of differentiation and integration are inverse processes. Inverse of differentiation is integration. Reverse of differentiation is integration. We saw other properties in the next class. You should know about the all integration of x to the power n and integration of cos x, integration of sin x. Then only we solve problems easily. First, we perfect about the derivatives and find the integration easily. I will continue in the next class. Thank you.